Hello YouTube, Ammar here and we're back with another video. In this video, I'm gonna teach you the Newton-Raphson method. I'm gonna explain you this method completely. I will solve a question applying this method, and of course, I will provide you the code of the Newton-Raphson method in the Python language. Okay, so coming on to the Newton-Raphson method, this is basically the formula of the Newton-Raphson method, and this method is similar to the secant method and the false position method which we taught in our previous videos. In those last two methods, we had to go towards the value of root using the 2 points, and in the Newton-Raphson method we're going towards the root through a single point. So moving on to the Newton-Raphson method's question, we're going to suppose the values and we're going to calculate the average of those two values, and we'll get a point through which we're moving towards the required point, which is known as 0. Okay, so we're going to put this value in the equation here, and we'll get another value which is known as 0.875. Of course, we're going to store these values in the chart here, and we will put the value of 1.5 in the another equation which is known as this f dash x naught. So basically this is we get to the equation after we differentiated this equation, and we're going to put the value 1.5 in this equation, and we'll get another answer which is known as 5.75, and of course we're going to store this value in the chart here. So we will put all these three values in the formula, and we'll get the value of x1 which is known as 1.347. So moving on to the next iteration, we're going to put this value in the equation, and we will put this value again in the differentiated equation to get two values, and we got two values 0.097 and 4.43. Of course, we're going to put these values in the chart here just to keep the record. And so we're going to put these values in the formula of the Newton-Raphson method, and we'll get another point known as x2, which we will not get another point, which means that we're going to get the value of x1 which will be updated to the x2 point. So moving on to the last iteration or next iteration, we're going to put this value in this equation, and see where we got this value 0.0011. So in the next iteration we're going to put this value 1.325 in the equation, and we got the value 0.001, which is a lot closer to the 0, and which means that in the next iterations we would get the value 0, and of course we got the required point. So we're going to put this value in the equation, and of course we're going to put the same value in the differentiated equation to get another value. Of course, we're going to put these two values in the formula to get the value of x3. We'll put all these values in the formula, and of course we'll get another answer. We will put these values in the chart here, and so that's basically it for the Newton-Raphson method. And I'm gonna code the Newton-Raphson method in the Python language. Yeah, stay tuned. Okay, so moving on to the code of the Newton-Raphson method in the Python language. First, we're gonna create a function named Newton-Raphson. The parameters we're going to pass is f, which is known as the f of x or function of x. The next parameter we're going to pass is the f underscore prime, which basically is the differentiation of the previous parameter which we passed. And the next parameter we're going to pass is the initial guess. Of course, it's the midpoint through which we're going towards the root. And the next thing is tolerance, which means the code is going to stop running when it reaches the value of 1 exponential minus 6. And of course the last one is the max iterations, that the code is gonna run 100 times. So we're gonna put x equals to the initial guess, and of course iterations are equals to 0 since we haven't applied a formula yet or haven't done anything yet. So moving on to the next step, we have applied a while loop, and we have put the absolute value of function of x, which means that we won't get a negative answer because of the absolute value. And so basically this while condition says that the absolute function, if the absolute function of f of x is greater than the tolerance and the iterations are less than the max iterations, then the formula is going to be applied. Only when the formula is going to be applied if it fulfills the above two conditions. And of course it's going to put iterations plus equals to 1 since we have applied a formula here. and it's gonna return x and the number of iterations. So x is the updated value which we have calculated over here, and the number of iterations it will increase. So on to the next step, we're gonna, this is basically the equation which we are gonna solve, and in the next step we're gonna differentiate the equation. Of course, differentiation of x square minus 2 is 2x, and the initial guess is 1, which means the midpoint value is 1.0. We're gonna go towards the root through this value 1.0, and in the next step we are gonna call all of these methods, and yeah, that's basically it. We're gonna of course print the root of the value and we'll eventually get the answer. So yeah, let's just run this program and let's see. So the value we got of the root is 1.41 and the max iterations are equal to 4, which means that we reach the value y equals to 0 when the root value is 1.412 and the code has run 4 times. So yeah, that's basically it for the code of the Newton-Raphson method, and if you have any questions, please comment in the comment section below and we'll make sure to answer all of these. And thank you for watching. See you.